Today, we are going to look at one-to-one and onto function. Why is one-to-one and onto function important? One-to-one and onto function is important because it is the only function that has an inverse. One-to-one function is when each domain has pairing with only one range. Onto function is when all the ranges have pairing. Let's look at example 1. Does this function has an inverse? It is clearly shown in the diagram that the domain has only one range. So this is a one-to-one function. Now let's look at set y. All the elements in set y have pairing. So, it is an onto function. So because this is a one-to-one and onto function, this means the function has an inverse. Next we look at example 2. This is a one-to-one function because the domain has only one range. Because not all elements in set y have pairing, this means this is not an onto function. So for this function, it has no inverse. Next let's look at example 3. This is a many-to-one function, because two domains share the same range. It is not a one-to-one function, but this is an onto function, because all the elements in set y have pairing. This means the function has no inverse. For the last example, that is example 4, this is also a many-to-one function, because two domains share the same range. This is not a one-to-one function. This is also not an onto because not all elements in set y have pairing. So, this example has no inverse. Now, we are going to learn how to sketch an inverse function, using the reflection of the original function at line y equals to x. Imagine the blue dots are the original function. Reflect the first blue dot across the line y equals to x. We get the first rect dot. Imagine the red dot as the inverse function. The same goes to the blue dot on the fourth quadrant. We reflect the blue dot across the line y equal to x. We will get the red dot. Imagine it as an inverse function. The last blue dot on the x-axis is also reflected across the line y equals to x, to the red dot on the y-axis. Now let us practice sketching the inverse or sum functions. We start with a quadratic function with a restricted domain. First sketch the line y equals to x, reflect the blue line, which represent the function, across the line y equals to x. We will get the red line, which represent the inverse of the function. Now let us practice with a logarithmic function. First, sketch the line y equals to x. Next, reflects the blue line which represents the function across the line y equals to x. We will get the red line that represents the inverse function. From the sketching we did just now, we can see that the graph of f and f inverse has the symmetry property. This means the graph of the function and its inverse are symmetric with respect to the line y equals to x.